Hey there, I'm Felix Clock, and I'm here doing a little demo trying to use Pernosco to help resolve an issue that a colleague of mine has run into. So, um, Pernosco, first of all, the issue itself, let me make sure I just briefly introduce that in some way, is um, it's a Rust issue, it's a Rust compiler issue. So the issue is issue 84946. Or rather, that's not the issue they're resolving. My colleague has a pull request to resolve that issue. The problem is that their pull request is having a roadblock. The roadblock is that something they changed in their pull request caused some change that made Rust format start producing different output, where Rust format is supposed to take this test input and it's supposed to be idempotent. A function definition looks like this, should go through Rust format and produce the same output again with the same comment in the same place. What, for some reason, my colleague Esteban's change is causing it to emit instead this code where it's duplicated some information in a way that doesn't parse anymore. So that's not good. That's very bad. So how are we going to resolve this? Well, the first step was to do a build of Rust format and be able to even run this code. So here I have the necessary function. In fact, what I'm going to do first, after I just realized thinking about it for another second, what I really want to do is I want to have another copy of this that's focused solely on the um, problem at hand, because these traces that we have with Pernosco, they are, they are not incredibly massive, but they're pretty big, and you don't want to spend time looking at stuff that's not relevant to the problem. So let's focus just on this one file and make sure that this produces the same output. So this is the problem. This single file here with just this one line produces now this output. Okay, this is the wrong output to produce. Next, I'm going to use RR to make a trace of this output. Now, I'm on an AMD CPU, so something I'm not showing you is that I had to do a workaround inside of RR where there's a certain script that's provided with RR itself to work around this issue with AMD CPUs. It's called the Zen workaround. It's in the scripts. It doesn't. If you're not on AMD, it doesn't matter. But I had to have it in place. I have it in place. I'm running an RR on the same command line invocation that I just ran a moment ago. RR runs, and we get the same output. Okay, that's not surprising, hopefully. The important thing is that we can now do RR-replay, and we'll see the same output again. Okay, and we can do, and it's all been saved into this trace directory here, Rust format 2. So what we're going to do now is we're going to use Pernosco and upload that area, that directory. I think Pernosco will automatically pack the trace, but in fact, because I'm not 100% sure of that, I'm going to pack it manually. So I'm going to run RR pack. What that does is it takes any external dependencies, like files that RR normally expects to be locally present. It puts them into the same packaged up thing, and so that way this trace is runnable on other systems. Now that it's been packed up into one big old package, we can run Pernosco submit and upload that same trace that's referenced in that earlier output. Okay, so we're going to do Pernosco submit. Oh, that's the other thing. Pernosco has a control mechanism where it wants to try to infer what the source code it can include as part of the upload, because it wants to have the debug info show you useful source information. So your trace probably didn't reference those source files directly. It referenced the binaries that those source files were compiled into. But Pernosco, it's a debugging tool and a web service, so it wants to grab some other files that weren't part of the trace, and namely the source code that's relevant to the problem at hand. And so the way Pernosco does this is you're supposed to tell it the root directories that it's allowed to search for source code in, because maybe you have secret stuff in other directories that you don't want it to look in, secret source that you don't want to put on its web service. I don't have anything on this system that I'm worried about leaking in terms of source code. This is all open source work, so I'm going to go ahead and put the root directory, and I'm going to hope that Pernosco doesn't doesn't rm-rf that. That's a joke. Of course, it's not going to do that, right? So here's what happens. It goes ahead and runs. It scans over and identifies the parts of the source code that are relevant, and checks whether there's been differences in those source files, you'll see that I have my own checkout of RR. I have my checkout of the Rust repo. It's looking, and then I had Esteban's pull request checked out and did the upload. It's uploaded to S3 now. And so now what I'm going to do is wait for Pernosco to email me back with information about this this run. Now, I'll be honest, I already did this earlier, and so rather than make you all wait, it doesn't. It just takes a few minutes. But since I already did a run on Rust, you might have noticed this is Rust format -2. I already did this upload with Rust format -1 or -1. So I'm going to go ahead and pull it up with that run that's already been processed. Maybe I'll let you know when the output when Pernosco emails us about this one if I happen to notice it. But this is the run, and so the interesting part here. Oh no, right. The whole point is I don't want to show you Rust format -1. I just realized the reason I don't want to show you Rust format -1 is because it's a longer trace. But we have it now. We might as well look at it. Fine, fine, fine. Let's go ahead and look at it. So the crucial thing that I wanted to talk about with Esteban was the fact that these got these outputs in a single line here, and we were curious about why this gets duplicated. So if I click in the output and I say, look, I want to know about this. Where's the line? This part right here. It's not actually letting me click that one character. Interesting. My experience had been, I had thought that I was able to actually see individual characters and individual lines, but maybe the whole thing's going to spit out as one big thing. That's funny to me. Okay, so let's see here. It's got paren inside generics, and it's saying which line F is that. So maybe it's somehow intuiting that I meant that thing. Unfortunate. So let's see. The I, data flow to the I there is saying it's this. It doesn't have much information, unfortunately, because there's, we can click to where this exact thing happened. That's right. My memory with RR is the way to go here is actually to show me the full trace of all of the instructions that were executed, because then you'll get to see like individual lines that were emitted. So if I say I want to know about this line that was emitted, where is it? See, this is why I really did want to focus on that one trace, because having to scroll up and down with this is painful. So if I click here, we got these calls to std write all, where it's just spitting out the whole thing, looks like, which is not surprising that it'd be a whole write out of all the stuff that's in the buffer. So that's not the interesting thing though. I want to know how this buffer ended up like this, right? And so in theory, I should be able to inspect the state of this buffer and find out more about what it looks like. So let's see, how can I find out more about this buffer? Local variables, maybe? Buff looks like this. Okay, it's going to be much longer than I want to look at, unfortunately. If I click here, do I get anything useful? I'd have to find out like what these characters correspond to. And my ASCII is, you know what? Let's go ahead and just jump the other trace. The other trace finished, so I'm going to pull that up instead, because it's more fun to look at something that's a smaller trace. So let's start over on this trace. This is the same trace as before, but the trace is much smaller, and so it's not going to be scrolling up and down with the trace as much. Okay, we're back to looking at this. So the question is like, why are we getting this I here versus this I down here, right? And so you can see that it's like has ways to inspect the data flow for each one of these cases, where you can say, look, I want to know about this I, and it's got that I bolded right there. Or I can click on this I, and it says this is the data flow to this I here. Okay, so you can trace backwards, I think, through where those things happened. I don't know if this will get us to our answer, but it's potentially going to. We don't know which one of these outputs is the wrong one, so we might have to look at both of them. And the other thing I wanted to do was, oh, it's right. So the other thing I was trying to do before was actually look at buff. It's possible we'd be better off with an even smaller test case, so that we can actually look at the buffer, like if the buffer actually fits entirely in, one place. But let's see, am I right about this being the right thing to look at? So like, for example, if this, is there a way I can cast this to a, no, It's too bad. I would really love to be able to see this as their corresponding um, ASCII characters, but I don't know how to do that in this context. So, but I'm pretty sure if I scroll down to like this is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 or so is where we'll start to see problems, right? It's really earlier. It's 18, 17, 16. It's either 16 or 15 that we'd notice a problem. Um, so this part where we write here to that part of the buffer, like I'd like to know more about how that happened. And there's lots of copies happening, right, for that 45. Hmm. And it doesn't have any data about that one. All right, how do I go back? Let's try again. So we were looking at 16. There's a lot of non-copy overlapping. And it's from these, in the stack trace, we can see it's from pushing these strings. Oh, look, okay, this is something. This is what we expect to see. This string here is it's bad, right? This is not. This is the bad thing, but it is what we expect to see. So we can still tell, for example, the stir is already wrong at this point. So, all right, when did the stir get up to being like this? And so we might keep traveling backwards in time to see how the data flow got to this point, and say, okay, we'll go up the stack a couple times here to this push stir. Okay, here's a push stir, and it's got this stir here. All right, and that's from context wrap items where it pushes the stir, and here's item stir here. Okay, and so the interesting question to me is, what is result? Result here is just foo. So this is the first. This makes sense in terms. This is the first item stir being pushed onto the foo, and the question is, okay, when does this part get? So this gives me some idea. This first section here of this whole thing, U all the way out to this thing here, is happening during this item stir push stir, right? Okay. Now, the question I have is, what about the other thing? What about this closed bracket, this A, and this other, it's really this open parent A, I guess, is really the heart of what we're interested in, right? Starting with this, I don't even know if I identified that correctly earlier. This first open parent here is maybe the first problematic thing. So let's see if we can track that down. So if we look at the data flow for how that got established, we can see that some copy non-overlappings that have to do with these calls to first reserving and growing and appending elements and extending from slice and push stir. Here's a push stir call right here. And if we look at this push stir call, this is from right stir. And what is the S in question here? Oh, unfortunately, okay, self is at this point already messed up. So I'm probably looking in the wrong spot at this point, or at least it's too late. At this point, self is already problematic. So let me hmm, I don't want that showing. Okay, so back to the question. Data flow to like this A, I think is what we were like the kind of thing we were talking about, right? As an example of something that I care about. So again, copy non-overlapping, scroll back, some visit item calls, two vec calls, slice hack to vec. I don't know. This is not necessarily as relevant immediately. Like this self is still just a string. It's rewriting the params. Rewrite the base. Result, generic stir. Oh, look at this. This might be a problem. We've got a result that looks like this and a generic stir that looks like this. Is that okay or is that not okay? Let's look more carefully. So where are we in the code base right now? So we've got This is a big function. Result, push stir, generic stir. Maybe this is okay. Maybe this is what's supposed to happen because this was from before. Let me see if we can jump back to this point in the control flow. So yeah, at this point, this is fine actually. This is what we expect, or it might be fine. I'm assuming that this is the correct thing we have happening here. So by the time we get down here, what's it look like? Never executed. Okay. They told me at some point when I asked the Pernosco team about my usage patterns, they recommended I make a new column because my pattern of working, it was like often creating new columns. They were stacking up over there, as you can see. But now I'm sort of stuck with this, still not going to where I expect. Do I need to move this thing over maybe? I move this one down here. All right, let's see what happens now if I do this way. Nope, it still ends up all the way over here. Okay, well, it's not an ideal user interface in my opinion then, in terms of how I'm going to make it not stack. It keeps doing that. All right, where was I? I think I already tried to establish that this seems okay, and I'm trying to figure out where things went wrong. So let's go back and look at the standard out and standard error again. So this, I want to know about this A, this one written right here, right? So that's what I care about. I don't want data flow to N, I want data flow to A, this thing. Data flow to A, okay, it says this. Oh, that's just the notebook. I don't want the notebook. I want to see this thing. Okay, the data flow is this series of things, and I can trace back through the data flow to see how it got copied over, over, over. And so an example of where this happens is this called a push stir from here. Okay, here param stir is A. So we're putting the parameters onto this foo. Oh, it is no, that's right. I'm mistaken, I think. We do want the parameter list. You see, I need to read this more carefully, what the original function looked like. This is my mistake, that I lost track of what the evil goal even is. So our goal is to make something that looks like this. Oh no, there are no parameters. Okay, there are no parameters. So for some reason, the paramster thinks it's supposed to have parameters on it. It's supposed to have A on it for some reason, it thinks. Why does it think that? So, because what's supposed to happen is an open and then immediately close, but for some reason it's got a paramster in here with A on it. Well, it's got this rewrite params thing. Arguably, I could maybe compare against another run. Tick, tick, tick. So I'm still thinking this through in terms of where could this thing have come from. And I'm still suspicious about what's happening here because we've got something going on where our result stir looks like this, and by the time that we flow, oh yeah, so I wanted to try to show you the instructions executed view. We look at that, move it over here. So the idea is that you can click around in this thing and see where you were, like in the control flow of the actual program. And the reason that that can be useful, depending on what you're doing, is it can make it easier to jump around within a function to like get some perspective on like how, like where things went from here to here. So if I click this, it says it's never executed. Oh, because the end of the function. I guess that makes sense. It's the return of comment to owned here. Okay, let me go up another level. Right, rewrite param, rewrite fn base. What about this? Is this executed? This is executed, and at this point, the result still doesn't have the thing on it. right, because we found out earlier or later that this is where we finally get the first brokenness of this program. So this, for some reason, this is being called, and we want to figure out how we're getting here in the control flow. So looking at the stack at this point, we add another column and bring the stack, dedicate the stack to this space over here. At this point, I'm doing it like if you can't beat them, join them. Just letting stuff accumulate over here as I click stuff and moving it over when I find it useful. So this stack right now is this. I'm suspicious about how we've gotten here. Because we have the rewrite fn base, and it eventually is going to do that right. That's questionable, that we've already been talking about, where it does this result push stir param stir. So this param stir comes from this rewrite params. I don't know if that's different or not between the earlier version of the code and the later version of the code. So that's a question. And this code is within Rust format, which wasn't changed by this PR. Is part of the whole problem here is that we're talking about a code base where we're seeing the problematic execution that has not been touched by the thing that's the original pull request changes. Okay, so let's see about the rest of this. So my assumption is that based on what I've seen, the param is just going to have A from at least this iteration or whatever's happening here. So I want to know more about what happens later in the function. So let's keep going down. So as we work our way down through the function, result stayed the same there. Here it, I think, is going to push on that close paren, right? And remember, the whole problem here is that this thing is going to end up spitting out this whole thing instead of closing the paren and doing open close, right? We basically everything here is what we think is wrong, depending on our point of view. So what happens now? Because our result at this point looks like this thing here. Does anything more bad happen before this particular function finishes? Yes. So where clause stir might be problematic. Nope, it's an empty string here, but you can see what happened to result. Somewhere between where I was up there and where I went down here, this whole thing got built up to this. So if I backtrace a little bit, look at this. Missing comment. Missing comment here. It says it's optimized out, but it looks like this here. Look at that, huh? That's the whole thing. I'm surprised that a missing comment would include things like arrow B and this stuff. So that's interesting. Where did the missing comment come from? So we can ask, what is the data flow for missing comment? Apparently it's anonymous. That's a shame. There's one problem with Rust compiled code is that it definitely produces stuff that Pernosco is not like, doesn't work so well with Pernosco, and it's possible that turning optimizations off would improve things here, but that build takes a while to make something with optimizations, to make the whole system with optimizations turned off. So I'm not going to do that right now. It's a big investment for something that may not pay off. In fact, the crucial thing here is there's this recover missing comment and span. I suspect that's the issue, that like I'm really suspicious that this is returning something that looks that the return value here ends up looking like this, right? And so my question is, okay, how do we get in this thing, right? What happened here? So if you go and look at this function, how do we do that? And the interface for RR lets you normally like RR is like a GDB style interface where you have a current point in the control flow and you're like you step forward and backwards, you can step into functions. I have not mastered how to like do the equivalent thing in Pernosco where you're seeing the whole execution at once. But I think a way to go, what I've used before, is to say, okay, look, it's showing me right now like this call in the instruction stream, and so you can just step forward in the number of instructions. That's a way of stepping. It's not maybe the most efficient, but this definitely got us into the middle of that function, right? And so from within here, we might get some idea of the kind of thing that we're expecting to see. Um, like this thing just says it returns an option of string, and it's got a rewrite missing comment call here. So I'm still pretty suspicious. Like I think that there's something wrong with we're messing up however Rust format expects to do its comment rewriting. Looks like it's messing up here. Um, so that's my first sort of guess as to like working backwards from what's going on. Like I'm looking at the execution of Rust format itself. This stuff looks like it got messed up, and then my question is why. And it might be how, I don't know how Rust format's logic works. Like, is it using the spans to try to infer where the comments are? Esteban and I noticed privately that the only thing that the parser had a difference on was the spans. There was a change of the spans from the Rusty's parser, and we thought that was weird to cause this kind of problem. But maybe Rust format is relying on the spans being correct in some way that we did not anticipate. Um, I could believe that. So I'm gonna take a pause here and send this on to Esteban. This what I found so far, and see what he says about his thoughts about the investigation so far. All right.